Good evening, everyone, and welcome to the Open House Melbourne presentation on the Sidney Myer Music Bowl, a structural engineering history, and with a little bit of social history and architectural history added into the mix. For those of you that don't know me, my name's Phil Gardiner. I'm a Principal Director of WSP. I joined Bill Irwin's practice firstly in 1979 and have worked through that era with the practice until they became part of WSP. I've had the joy of working on some of those original buildings from the 1950s and onwards, and continue to have massive admiration for what was achieved. Right now I'm going to take my head off screen and take you through a series of videos, photos, original drawings, and talk through what the structure of the bowl is and how it works. Starting here with some drone footage. We've started on top of the canopy last Friday on a foggy Melbourne morning, and sweeping up to get a good view of the overall canopy, of how it sits in the King's Domain and the surrounding gardens. And we know where that park sits, right on the southwest corner of the southeast corner, of the CBD. Beautiful gardens with the Botanical Gardens, Alexandra Gardens, King's Domain. We've got the shrine just up the road, and across the river we've got the sporting precinct. And just there you see that beautiful shape of that canopy and the silver alum ply cladding. Just to move on now and put it in context of also where it sits in the city. We're looking across from the bowl now, across the river towards the rectangular stadium, the tennis centre, and immediately on the other side of the river is the Olympic pool. Bill Irwin's first project, which he won in competition with the McIntyres, Borland and the Murphys. And I just wanted to put it in context with the sort of work that was happening at that time. And I'll use Bill's projects to demonstrate that. So this was an era where post-war there was an abundance of labour, but building materials were still in very short supply. So this resulted in some great modern minimalist buildings. The pool was the first, a series of three of these for Bill Irwin, with the dome being awarded next, but finished after the bowl, and the bowl awarded within a couple of months of each other. So yes, the pool we all know, and I've spoken about it before. The dome was Grounds Romberg and Boyd, and it's another beautiful structure of its time, using the minimum amount of materials with a very thin concrete shell, which is in fact a perfect compression structure. And I always think of the bowl and the dome as being the yin and yang of each other, with, as I said, the dome being that perfect compression structure and the bowl a perfect tensile structure. Just moving forward, looking at those three jobs in comparison, the internal shot of the pool as we remember it before it was converted, external shots of it under construction with the girders and the tie rods, difficult to see there behind the trees. It's the world's first post-tension steel structure, and like all of these buildings, the stadium shape of the seating, the roof, that enclosure to enclose a swimming pool with seats, the structure perfectly follows that representation and delivers it beautifully. Again, a bit space age for the time, a bit like something from the Jetsons that we watched when we were a kid, but a beautiful, beautiful, mathematically pure structure that has stood the test of time. And that was followed by the bowl. I've always sort of wondered how these three buildings are quite radical in their form, and in fact that whole architecture movement of the time, and even the arts, quite bohemian. Whereas we know Melbourne was a very conservative society in the 1950s, but great buildings, great innovative and quite radical buildings were delivered. I hate to think how we'd go delivering something that was so out of step with society's norms today. We probably wouldn't get them up, but thank goodness they did get that up in this era. So the Sidney Myer Music Bowl, first envisaged back in the 20s and 30s. the Music for the People in the park was happening in the Botanical Gardens. So Sidney Myer apparently did enjoy touring the world and looking at outdoor performances. But after his passing, and with his estate, the bowl was envisaged as a real project in 1955 with funding from the Sidney Myer Charity Trust. And a joint competition or joint design approach was held with Grounds Romberg Boyd and Youngcombe Freeman Griffiths and Simpson. GRB were in the box seat as the senior members of the team, and they were developing a scheme that was very much inspired by the Hollywood Bowl as a concrete compression structure until a young, then Barry Patton, emerged with his tensile tent structure. And apparently, the history says once it was presented, the board loved it, and that is what was delivered. Now, that commission was granted to Youngcombe Freeman's and Bill Irwin as engineer in 1957, mid-1957. And the bowl opened in February 1959, so 18 months from design start to completion. Quite a task, again, something we'd struggle to do in these days. So this image from The Age shows the first performance. It was a joint performance between the Melbourne Symphony and Sydney orchestras, opened by Sir Robert Menzies. We know the bowl has hosted a lot of very significant concerts over the years, and this is now getting more towards my era, although I was a little bit young for this one. This is a world record crowd of the Seekers in 1967. Sorry, when I say world record for the Southern Hemisphere of 200 to 220,000 people swelling across the gardens to watch the Seekers right in their heyday. My own sort of exposure to the bowl, like many of you, started with the Carols by Candlelight. And one of my first memories is very rainy nights. But my first real concert, and we're bringing up the music now, at the bowl was the 1972 music concert, headlined by Billy Thorpe and the Aztecs, Max Merritt and the Meteors, the La-Di-Dahs, a few other bands, and I was there again with about 200,000 people in the crowd, and I just remember the excitement of that venue at that time, and was then lucky enough through my engineering degree to have a part-time job selling donuts, cooking jam donuts in a van and selling them. And the best venue I worked at was the Sidney Myer Music Bowl, and I was very fortunate to see the Eagles, ELO, Neil Diamond, Bob Dylan, Rod Stewart, the Beach Boys, Wings, and Fleetwood Mac in that era where most young gentlemen my age quite liked Stevie Nicks. So it was a great era, and I was very lucky to get a whole lot of free concerts while I was there. But rather than just talk about the social history now, we should go back to the design. And I'm going to move on from that slide, Seekers, and move on to one of the really early concept drawings for the bowl. This is just a longitudinal section. It shows a representation of the catenary cables across those tapered masts, with the stage and the understage back of house, and some fairly massive foundations there to anchor the cables at the rear end. This design was delivered, as I said, by Youngcombe Freeman, Barry Patton with Angel Dimitrov as the main team, and for Irwin, W.L. Irwin and Associates, as it was back then, Bill Irwin with a rising young star, Roy Johnson, who also happened to have a degree in mathematics, which was very useful at the time. Drawings have been reproduced from our microfiche. I trust if you're on a screen, you'll be getting some detail. If you're watching it on your phone, you'll get a flavour, but you won't pick up the detail. That long section of the bowl I spoke about showed the profile of the catenaries. This aerial view though, and back in the era when we drew by hand, if a building was symmetrical, you only drew half of it. So hence we've drawn half the building here. And if you wanted to count and then work out the other side, you'd see there's 35 main cables running down to that main anchorage at the end into a 13-metre deep foundation pile. And each of those cables has a load of about 30 tonnes of tension in it. So some very significant forces going back to that anchorage. The transverse secondary cables, the ones that run across the page, they're only got about 14 tonnes. They're working much less hard. But if I go back to that long section, if my screen will allow me, and it won't, so we won't, I would have highlighted again that those up and down the page cables have that beautiful catenary sag, which carries all the weight of the cladding. The cables in the other direction are convex, so they're catenary but upside down, and they resist the wind load. A very simple engineering principle of one set of cables carrying gravity, the other set carrying wind loads. Just to compare, looks like the same drawing, but it is slightly different. This one was the original concept, and it's a little bit narrower in the canopy than what was finally adopted. So yeah, it's a good thing that we maybe got a little bit more area. Otherwise, we might not have got that record crowd. Unusually for the time, this was quite a high-tech building. The team consulted with the CSIRO as well out at Fisherman's Bend. This shows an image of the structure being tested for wind. And a wire model was built, and I understand that they knew they had the tension in those wires correct when strummed. They hit a perfect middle G. The cables themselves, I've described them as a catenary profile, and they are mathematically, it's quite pure. And as a structural engineer, we love it when structures make sense and we're not trying to make something work that's not exactly in accordance with the principles of nature. So these cables mathematically are quite pure. Roy Johnson, no computers at the time, so with his logarithmic tables and his slide rule, and apparently hanging strings on the wall to fine the shapes for sag versus span, came up with this design. I guess one of the other high-tech initiatives of the time was the alum ply cladding. That's a composite panel of plywood with aluminium bonded both sides. It was a product developed by the French aviation industry pre-World War II and was originally used for aircraft fuselage. I'm just going to move on now to another drawing which showed an alternative to the alum ply cladding. And what this is showing us is little pyramid-shaped thin concrete shell elements that would have been laid across the canopy as a tile. It wouldn't have had that beautiful smooth profile. It would have had a very dimpled effect. I think we can probably all be thankful that the alum ply was the scheme that was adopted. Now, a few videos coming up now that I'll use in conjunction with the drawings to describe the structure a little more clearly. So first video coming up here, and we're going to sweep across the front of the bowl. As we're doing that, I'm going to pause that video momentarily and highlight. You can see the main cables coming across the top of the columns there. We can see the seats, the stage, altered somewhat from the original design. And importantly there too, I'd like to point out those arches inside the canopy, again, not original, or the lighting gantry. And these were all the work of a major renovation of the bowl in 1998, done by Gregory Burgess, architect, with Arup as his engineers. They obviously improved the functionality of the bowl. They improved the back of house with real amenities and improved the public amenity for toilets and other things, and a cafeteria. And probably most importantly, extended the canopy further. So if you wanted to count the transverse secondary cables now, you would probably count 27. Whereas if you went back to that original drawing that I was looking at earlier, you would have counted 21. And that was to give more shelter over the seats, because those seats were very much still in the weather, in the Melbourne weather, and we know what that can be like. I'll just finish that video as we sweep across the tables. You can see those cables across the mast extending to the big anchorages that disappear quite neatly into the ground. What happens below ground though is quite significant too. And again, that cable is buried another 13 metres, 40 feet into the ground for a dead end. A few images now after this video. Sorry, we'll see that cable in a little more detail before I move on to photos and drawings. We see all the connections there of the primary cables and secondary cables coming in to that main cable. The secondary cable anchorage is disappearing very neatly into the turf. This is a drawing of the anchorage of that main cable. Again, quite simple but effective. 13 metres, 41 foot 8 inches into the ground, 54 foot 4 inches, which is more like 15 metres, 16 metres horizontally projecting onto a large concrete dead end to take out the load in that massive. I'm just going to pause there as we lost a slide. Starting my recording again, we can see that main cable being rigged. It weighed 7.5 tonnes, the cable alone, and getting that cable up and the main mast was the most difficult part probably of the job, the most significant activity. Once those were up, you had something else to work from. They required a full scaffold, and we could see the images of the riggers there working on that. With no UV protection, no safety harnesses, and no fall protection. The archive again says these were Italian riggers brought in specifically for the job, more like circus performers, I think, but it was the job they were trained to do, and they did it safely. More like bridge construction in that view than like constructing a building. This next video is going to take us from that anchorage on the main cable and sweep up with a view from the top. We looked at it from the underside before. Again, this one gives you a better look at that alum ply cladding. We can see the secondary cables as well, quite small by comparison, disappearing into the ground. All of those cable clamps attaching to the primary cable, sweeping up to the saddle over the main column, and then down through the centre span with that lovely drape, casting a shadow into the park below. The alum ply showing its patina of weathering, but otherwise in really good condition. 22 years from when it was replaced, and it did 42 years in its first lifespan with just some minor repairs. Second mast. I love these drone shots, and we sweep our way down. In the occasional shot, you might see a couple of people standing on the lawn. That is the drone pilot. And we get to the anchorage at the far end. Really good way to see how that structure is working. I'm just taking you now to a drawing that shows the details of that main saddle over the column. So on the middle right of the drawing, the left-hand side of the drawing we'll come back to later after some further videos and images, but we can see that saddle over the top of the main column, a true pin connection. The main cable is made up of 7 cables, and then clamp fittings to the saddle, and above and below you can see then how the longitudinal cables are connected to the main cable, and the secondary cables connected to the longitudinal cables. Simple but effective details. A little pause there while we got back to the right slide. Not as easy to do while you're recording as with normal PowerPoint presentation. We're now doing a shot up the axis of the canopy from that rear anchor. 35 primary cables. We can see the secondary cables running across the top, anchoring into a retaining wall structure at the end, and then later on just disappearing into the earth. you get a feel for the shape of that canopy. It does flatten out a bit, flattens a bit more with the 1998 extension, bringing it forward. But it's still got that convex curvature as opposed to the catenary shape of the primary cables. And then we're going to sweep up and look back at the city again. Again, putting it in context. So the axis of the bowl pretty much lines up exactly with, I guess that would be St. Patrick's Cathedral. Don't know whether there was anything intentional in that, or whether that's just the way that it happened. So this drawing shows the anchorage at the back where we saw those 35 cables coming in. It's again a significant concrete element, 13 metres into the ground, big concrete wall, but again 35 cables each with about 30 tonnes is a big amount of load to take out. The next video is sweeping down the side of the canopy to highlight those secondary cables. I'll get that started. Oh, there's our drone pilots sitting on the grass, one of them having a little bit of a rest with the dogs in the background. As we sweep down the side, you can see all of those secondary cables, 27 of them. Very simple termination, that convex shape, just such a lovely geometry. It gives you that good overview of how that structure is working and the anchorage into the ground. We'll take you from there to a photo that shows that construction, archival photo during construction, but from the other side. A little bit of a messy construction site. We can see the earth embankment, which up until the 1988 renovation was just a sprayed concrete wall. We can see the alum cladding is starting, and if you look, you can see a couple of things hanging from the roof, and they're actually concrete ballast weights to help get the cable into the right shape before the cladding is added, so that when the cladding is on and you take the weights off, it's all in the right spot. You're not getting a lot of movement at the joints as you put the cladding on. This is an earlier shot, which is a really great way to get a look at that cable net. You can see the weights hanging there again to get it in the right shape, and we can see our Italian riggers again, just hanging on the wires there like it's just part of their everyday job. Apologies, my management of the video went off a bit there, but here we go. We're creeping down the column, seeing that vertical seam that's been welded, getting to the middle where there's a middle joint, and all the way down the seam to the bottom, and the original signage, Sidney Myer Music Bowl 1959. Even a beautiful little graphic in its own right. I'm going to take you back to the drawing we had up earlier now, which highlights that column. You'll see that there. You can see the base detail. You can see the welds on the detail, the splice detail in the middle of the page, and the mast detail itself. You can see that taper from 760 millimeters in the middle to 380 at each end. There is a formula there. If your screen's got good enough resolution for the parabolic formula of 30 minus h squared on, might be 83.75. That's all in inches. So that actually gives the set out for the column. I imagine this was a bit of a fabricator's nightmare, but anyway, that is what it is. It's probably a good time too to point out that the builder for this was McDougall Island, who was also the builder for the Olympic pool. Bill had a lot of great collaborations with McDougall Island back in that era. And I probably should have acknowledged that the builder for the dome was Civil and Civic, now Lend-Lease, a very, very early job of those in 1953. This detail here also shows, this drawing shows the details of these, the secondary cable anchorages going into the ground. on the left-hand side of the page. Much less load, each cable anchored individually, so a much smaller foundation to deal with that. Now we're going to have a panoramic view to just again with a little bit of background music to put the thing in context of the whole of the city. Slides to finish. I'll hold on that shot there of the bowl, looking into it, and as that music fades out, it's probably a good time for me to give a few credits. So I'd like to thank Creative Kicks Media for the video footage that they did from the drones. I would like to acknowledge the archival footage we got from The Age and some of the newspaper reporting of the time. Some research that Conrad Heyman did on the bowl for us for a book on the history of Irwin Consult, and also a paper that Greg Burgess gave me, written by Harry Edquist at the time that work was done in 1998, and to thank Greg Burgess as well for his generosity in talking to me about the project. I hope you enjoyed that presentation. I hope next time you go to the bowl, you look at it with another view, a more informed view, and I hope you look at it with the love that I certainly feel for it. So thanks for the presentation, and I hope to see you all in person one day soon. Thank you.